Hi, everyone. In this video, we're going to start Chapter 3, Numerical Techniques for Describing Data. So moving on from Chapter 2, where we were still describing data, but we were describing it using tables and/or graphs. So we were visually describing our data. So in Chapter 3, the main idea is going to be describing data, but it's going to be numerically. So 3.1 is going to cover the first technique, or techniques, I should say, for describing data, which are specifically going to describe the center of a distribution. So measures of central tendency. So the key here is central tendency. Now, you're probably familiar with the three ways in which we can describe the center of a distribution: the mean, the median, and the mode. So some of you are familiar with those three M's. If not, that's fine, because I'm going to go over all of them, but just in case some of you might already be familiar. And these three measures, mean, median, and mode, are referred to as measures of central tendency. We could also think of another word would be average. They're all averages, but we don't use the word average. So I'm going to try to stay away from the word average, because now we're going to have three averages, not just one way to calculate the average. The most common or familiar way that you guys usually think of calculating the average, because you guys have heard that word for many, many years in school, average, that's when you add up all the numbers in a data set and divide by the total amount of numbers that are in the set. It has a specific name, though, in statistics. It's called the mean. So we're going to refer to it as the mean rather than average, because it could be confusing, since there technically are three different measures that we could use as averages. So we're just going to call them measures of central tendency, and they're the mean, the median, and the mode. So measures of central tendency are very important because each one of them in their own way lets us describe with a single number the center of all the data values in a set. So first, let's start with the mean. So the first measure of central tendency that we're going to cover is the mean. The mean of a sample. So first we're going to assume sample, then we'll talk about population. The difference isn't in the formula. The formula is the same, as you'll see, but there's different symbols. So you're also going to be introduced to new symbols in this chapter. So the sample mean is determined by summing up all the data values of the sample and dividing the sum by the total number of data values. And the symbol that we use for the sample mean is X bar. And here's your formula for X bar in symbol notation. Let me circle it also. So X bar is equal to the sum. So in case you're not familiar, this symbol here is our summation symbol. So we're going to sum up all the data values in our set, which we typically refer to as X, and we're going to divide by the sample size. So remember, lowercase n is sample size. Now, let's suppose we had a population, but remember, most likely the data that we're going to be working with is sample data, because remember we talked about in Chapter 1, it's often impractical or impossible to obtain all the data values of a population. So many times we use a sample instead. So most of the time, realistically, we would be able to calculate X bar from a sample. But let's assume, it is possible sometimes that we have data from a whole population. So we could calculate the population mean, but we have to use a different symbol. We can't use X bar because that represents the sample mean. So we call the mean of a population mu. It's a Greek letter. It's called mu, and that's spelled M-U. And it looks like the letter U, so it's kind of easy to remember. And that's equal to the sum of all the data values in our set. So it's the same numerator as when we were calculating X bar, except now we have to divide by the size of the population, which is capital N instead of lowercase n. So it's different symbols. So let's do an example. Let's look at example 1. So example 1 says, a statistics instructor gave the following final exam grades to a sample of her students. And there's the sample of grades. Compute the sample mean final exam grade. So I want to calculate X bar for this sample set. Now, how many data values are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my sample size, N, is equal to 12. So the way we're going to get the sample mean X bar is that we have to sum up all of our data values in the set. So we're going to sum up these 12 test scores, and then we're going to divide by how many there are, or our sample size, which is 12, or lowercase n. And let me just write that more neatly. So I'll give you guys a minute to pause, and you could add up these numbers in the data set. I'm going to do it as well. I'm not going to do it using my calculator with you just because it's time consuming, but I know you all know how to enter these data values into the calculator and just add them up. So add up 86 plus 82 and so on and so forth. So I'm going to have you guys do that and get the total. So when you sum up those 12 data values, you should be getting 918. So the sum is 918. And now we have to divide that by the sample size n, which is 12. And now if you divide that out, 918 divided by 12 is going to be 76.5. And that's going to be the sample mean. So let's interpret what is 76.5. So we had 12 grades here that range anywhere from 86 to an 82, 196, right? There's a lot of variability in these scores. But the score that represents this data value the best, that represents the center of this distribution the best, is a 76.5. So that's where the center is of this distribution, and we call that the mean. Now, this wasn't so bad doing it by hand, right? We had to add up 12 numbers and then divide by 12. Not too bad, right? I mean, it took a minute or two. But think about in real life, if I had 1,000 numbers, it's going to be very tedious to have to sum them all up by hand. So the calculator does have a function that will calculate the mean for us. So on the next section of your worksheet, I have using the calculator to find the mean, and I have the steps. So the first thing you're going to do, so let's do this together. What I want you to do is the first step is you have to enter this data set into a list in the calculator. And we've done this before. I showed you how to do this in chapter 2 in the previous videos. So if you have to pause it, go ahead, pause for a minute, and I want you to enter these 12 data values into a list in your calculator. So once you have this list into the calculator, and I'm going to share my screen, I already have my list in the calculator. I put this list of the test scores in L1. You see my 86, 82, 100, and so on and so forth. We don't have to sort it. The calculator doesn't need it to be sorted. It's going to calculate the mean for you without sorting it. So don't worry about doing that. So what we're going to do is we're going to press stat. So press the stat button. And then you're going to arrow over to the right. So you see we have our arrow buttons. We're going to take the arrow to the right and we're going to highlight calc. And you'll see option 1 is one variable stats. So we're going to choose option 1. So now the calculator needs to know, where did you enter your list? What's the list name? By default, it puts L1 there, but maybe you used L2 or maybe you used L3. So you're just going to type in the appropriate list. I used L1, so just a reminder, I'm going to clear this out, pretend like L1 wasn't there. I'm going to press second and then the number 1 key, and that's going to pull up L1. If you used L2, you would pull up L2 and so on and so forth. We're going to arrow down to frequency list, leave that empty, nothing should go there, and then arrow down to calculate and press enter. Now we're going to see a whole bunch of output, but the first thing on the screen is X bar. So X bar is the first output that comes up, and it's 76.5, which is the same mean that we got when we calculated it by hand. See how much quicker this is, especially if you have a larger data set? So X bar, the sample mean, is the first thing that's going to be listed in the output when you do a one variable stat. Underneath it is the sum of all the X values, which is equal to 918, which we also did by hand. And then underneath that is the sum of all the X squared values. So if we were to square every data value in the set and add them up, it would be equal to 73,866. We're not really going to need that in this course. And then the other output, which comes below, I'll talk about at a later date. Now, I do want to point out, notice that it only gives you X bar. It doesn't say mu, because X bar and mu use the same formula. It's just different symbols. So the calculator is always assuming that you're using sample data and that you're calculating X bar. But if you were doing a problem where you need to find the population mean, mu, you would use the same steps and you would use X bar as mu. So that's how we would find the mean using the calculator. Now, going forward, when we calculate the mean, I'm going to keep using the calculator. There's really no reason why we have to do it by hand every time. So the next measure of central tendency that we use sometimes is called the median. And some of you are familiar with the median. Median, think middle. The median is just the middle value of a data set after they've been arranged in numerical order. So it wouldn't make any sense if you have raw data that's not ordered and you pick the middle number. It wouldn't mean anything. You have to order the data from lowest to highest first. So whenever we're going to determine the median, the first step is to arrange the data values in numerical order from smallest to largest. And then the second step is if you have an odd number of data values, the median is the middle data value. You would just count into the middle number. But if you have an even number of data values, the median is going to be the mean of the two middle values. And I'll show you an example. So let's look at example 2. It says the number of times a vehicle ran a red light during the day at a particular intersection in Nassau County was recorded on 7 different days. So on one day, there were 3 vehicles that ran a red light. On the other day, there was 0. On one day, there were 7, and so on and so forth. So what I want to do is calculate the median. And first, I'll show you how to do it by hand, and then I'll show you how to calculate it using the calculator. So the first step is to put these in order from lowest to highest. So we're going to have 0, 1, 2, 3, 4, 6, and 7. So now my data values are in order from lowest to highest. And now what we're going to do is we're going to find the middle number. And we have an odd number of data values because there's 7 of them. So if we count into the middle number of the set, it's going to be 3. So the median is going to be equal to 3 in this case. And there's no special symbol for median. You know how for the mean we had either X bar or mu, the median, there is no special symbol. We just call it the median. Now, we can also use the calculator to get the median. To find the median, it's the same steps that we used to find the mean. And you know what I'll do in parentheses up here? So using the calculator to find the mean, and I'm going to put in parentheses and median. So you're going to follow the same steps. So we'll do it together again, and I'll show you where the median is. So if you want to pause for a minute and enter these numbers into your calculator, and you don't have to sort them. That's the nice thing about the calculator. If you're going to find the median by hand, you have to sort the data. But if you're going to use the calculator, you could enter it in the order that it appears on the paper. So I want everybody to enter this data set with these 7 numbers. Now I already entered my data into the calculator, so I'm going to pull up my list. And I put this in L2. So you'll see in L2, there's my 30722164. So we're going to take the same steps as we did to find the mean. So once we enter our data into a list, we're going to press stat. We're going to arrow over to calc. And then we're going to choose one bear stats. And we have to enter the list name, right? So I'm going to change L1 to L2 because I put my data set in L2. So I'm going to press second and the number 2 key, and L2 is going to pop up. Frequency list, empty. We're not putting anything in the frequency list. If there's something there, clear it out. And then we're going to arrow down to calculate, and we're going to hit enter. And it's going to give you the same output that we had when we, looked at the mean in the previous question. Obviously, it's going to be different numbers, but the output that it's going to give you is the same. So in order to see the median, what we have to do is we have to arrow down to the bottom of the output. So I want everybody to press their down arrow all the way to the bottom. And you see three up from the bottom is MED equals 3. MED is the median. And it's equal to 3, just like we got when we did it by hand. So you could also get the median by using the calculator. And going forward, I'm urging you, when you do homework or practice questions or a test or a quiz, I want you to use the calculator to get the mean and the median. Enter the list, do a one variable stat, and you could find the output that you're looking for. So the median in this case is equal to 3. Now, before we get to the mode, I want to show you what would happen if we added an extra data value to this set to make it even. So for example, what if we had 0, 1, 2, 3, 4, 6, 7, and 10? So what if I add an 8th number here? When we go to count into the middle now, there's going to be 2 numbers in the middle. The 3 and the 4 are going to be the 2 numbers that are in the middle. So now what we have to do is take the mean of those 2 numbers. So you're going to take 3 plus 4, divide it by 2. And that's going to be your median. So it's going to be the mean of the 2 middle numbers. So 3 plus 4 is 7. 7 divided by 2 would be 3.5. So that's how we would find the median if we had an even number of data values in our set. So I did want to point that out. But again, if you're going to use the calculator to find the median, you don't have to worry about doing it by hand. So the last measure of central tendency is called the mode. And the mode is the data value that occurs the most frequently in the data set. And a data set can have more than one mode. If a data set has 2 modes, we call it bimodal, bi meaning 2. And then if a distribution has more than 2 modes, at that point, we would just call it non-modal. So let's look at an example. So example 3 says the following sample represents prices of the TI-84 plus Silver Edition calculator at 7 different stores. And there's the 7 different prices. I want to find the mode. And the mode is the data value that occurs the most frequently. So let's scan these calculator prices. And is there a price that repeats itself more than the rest of the data values? If so, that's your mode. So it looks like I see 129.99, 129.99, 129.99. So we see that 3 times, which occurs more than any other data value in the set. So that's going to be our mode. So 129.99 would be the mode in this case. Now, unfortunately, there is no function in the calculator that will calculate the mode. It was possible for the mean and the median, but there is no mode in that output. So whenever you're going to look for the mode, you kind of just have to scan your data set and look at which value occurs the most frequently. If it's a large data set, you could always put the list in the calculator and sort it, and then it's going to be easy to go through it if it's in order and see if there's a data value that repeats itself more than the rest of the data values. So I'm going to stop here. In the next video, I'll go over the relationship between the mean, the median, the mode, and why one might be more useful than another.